So, there are implications here for the origin of time itself. Recall that space-time is a property of this universe. Time is a physical thing. It's substantive. It's something that's real, that actually elapses even if no events are occurring. Time itself had a beginning. Now, let's call the cause of time, let's call that omega, for the sake of just putting a letter or symbol on it. Let's assume that time was caused by omega. Of course, omega is also the cause of space, matter and energy, and physical reality. So what we're really talking about is, what is omega? What is that? Well, to avoid the circular fallacy, it requires that omega must be able to exist independent of time. Because you cannot assume there exists something dependent on the existence of time to explain how time came into existence. That would be a circular fallacy. So whatever it was, whatever omega is, necessarily, it's logically necessary that it be independent of time itself, physical time, or any kind of substantive time. In other words, it's timeless. Now that's interesting, because the next question is, well, what caused omega? But you can't ask that question if omega is timeless. Because the moment you ask that question, what caused omega, you were assuming there was a time when omega did not exist, but recall, omega is timeless. It's logically impossible for omega to have a cause. Think about that for a second. The infinite regression ends with omega, and that's just cold, hard logic at work. We're not quoting any Bible verses here. We're not making any, appeals or assertions, blind leaps of faith here. It's just cold, hard logic at work. Circular fallacy inexorably brings us a checkmate when it comes to the nature of omega and the end of all infinite regressions as far as physical reality goes. That is interesting. Once we are now in a position actually to formulate a logical argument, the ultimate cause of nature must be either natural or not natural. That would be a true dichotomy. You've got to be aware of false dichotomies. False dichotomies is where there's a middle ground. But in this case, it's either natural or it's not. That's a true dichotomy. Not natural, synonymous with supernatural. You can use whatever term you find yourself most comfortable with. Because I find a lot of people get uncomfortable with supernatural, but they're comfortable with not natural, but it means the same thing. Well, the circular fallacy dictates, logic itself dictates that the cause of nature cannot be natural, as I've already explained. This is a true dichotomy. It's what's known in logic as modus tollens. When you have a true dichotomy, one's eliminated, the other has to be true. Therefore, the cause of nature must be supernatural. It's for this reason that Hawking says, if you have a beginning to all things, a beginning to ultimate reality, we then have the problem, in his mind, of the hand of God. But it doesn't stop there. We already saw also that the cause of time must be able to exist independent of time in order to bring time into existence. Therefore, time itself, the cause of time cannot have a cause itself, as I explained earlier. Otherwise, there would be a time when it did not exist and something caused it to go into existence. Therefore, the cause of nature, and this is just summing up of the logical conclusions thus far, must be supernatural, timeless, uncaused, and eternal. This happens to coincide with a generally held notion of God that many people have had, many civilizations throughout history, just a very general, intuitive notion of God that we, many of us, or some of us, thought was just something that emerged over time, but if such an entity exists, it may be quite the opposite. We may have some foundational knowledge here, some a priori knowledge that of Omega, of God in the general sense, as the ultimate creator for all physical reality. But there's something more here. Penrose, a colleague of Hawking's, has focused a little bit of his time on this idea that the universe appears to be incredibly fine-tuned in order to support life. In fact, that was in a review in Nature, published within the last year, that I think it was Penrose that did the review. He was reviewing another book on the various multiverse theories, and he said, basically, The reason that we have come up with these multiverse theories is it's so wildly improbable that we would have any universe at all capable of supporting life that you need virtually an infinite number of them for us to get lucky. And that is the primary, according to him, in this review published in Nature, that's the primary rationale behind invoking multiple universes. But he says something here. If you take all the possible universes, look at collection of laws of nature. Let's talk about laws of nature because they can really vary, and physical constants. And you have the set of all possible universes as far as different laws of nature. And then you take the subset of universes capable of supporting life. The chance of falling within that subset is 1 chance in 10 raised to the 10 raised to the 123rd power. And that's why it's thought you will need, in fact, it is, the fact that this universe appears to be incredibly fine-tuned is actually, in some scientists' minds, evidence that there must be an infinite number or almost a very large number of universes, because there's no way we would get a universe capable of supporting life otherwise. Unless, of course, we have the hand of God involved here, which I'm arguing that we do. We have to invoke that sooner or later, as we already saw. But this universe here appears to be, I like to invoke Occam's razor. So instead of appealing to an infinite number of unseen, untestable entities to explain why this universe appears to be fine-tuned to support life, I would like to appeal to Omega, the ultimate cause of all reality. And Omega has designed, basically I'm talking about God here, God in the general sense, the creator of all things, uncaused and so forth, that we logically showed in the previous slide. That's what I would appeal to using Occam's razor, that there is a God who has actually designed this universe with something in mind, that it be able to support life. Now that is interesting because it suggests that if so much effort has gone into designing a universe capable of supporting life, there must be some point to it. And therefore there might actually be a point to our own existence. Conclusions thus far, just summarizing this section here. The cause of nature / the universe / M theory system is a supernatural, uncaused, timeless, and eternal mind. Why do I say mind? Because it seems to have an intention, and the fine-tuning of the universe to support life seems to point to a purpose. And if there's a purpose for designing something, there seems to be a mind behind that design or that purpose. To have a purpose, that's a property of a mind. Minds come up with purposes, goals, objectives, concepts. This corresponds to the general notion of God. This especially corresponds, and I want to point this out here, especially emphasize this, to the Judeo understanding of God as I am. That is the primary name that God said he would be known as. I am, the present tense of the verb to be. A timeless being for whom there is no past, no future. Occupies all points of physical time simultaneously. And you can do that if you picture 2 reference frames. The ultimate reference frame, we'll call that God. You have a smaller reference frame embedded within the larger one. That smaller reference frame at every point will God will intersect this smaller reference frame at every point, even though God is much larger than this smaller coordinate system or reference frame, which represents our physical reality. So the conclusion is this. The question was, how well has science done in explaining the origin of nature? And what I'm contending here is that science will never, ever explain the origin of nature because of the circular fallacy. Science is founded on the laws of nature. It's founded on nature itself. We cannot do science without nature and the laws that govern it. But because of that, and because we cannot assume the existence of nature to explain how nature came about, that whips nature out from being a candidate, and if nature is not a candidate, that whips science out. And that's why this Hawking said science breaks down at that ultimate point where all nature begins. At least that's why I think he's saying that. He didn't explain himself. That's, but what I've offered here is a logical reason why he would have to say that. So what I'm doing is it's one thing to appeal to an authority It's quite another to understand why that authority must say what he says. So what I'm suggesting here, what I'm trying to do with you, is to help you understand why Hawking would have to say the things that he's done. Part 3, how well is science done in explaining the origin of life? Kunin, a couple of interesting, his first paper on this issue where he suggested this was in 2007. He had a book that came out several months ago, The Logic of Chance. I think it's called The Logic of Chance. I've got it downloaded on my iPad. I've read some of the interesting bits already. He argues again that the probability, basically his argument in a nutshell, the probability of getting any of just the RNA replication system going for life is so small that you're going to need an enormous number of universes to hope to have it happen anywhere, at least in one of those. That's his solution, right there in a peer-reviewed paper in a science journal. Couldn't believe my eyes. A recent article just published in a few months ago. Don't tell the creationists, but scientists don't have a clue how life began. Now, if you actually read the article, it actually says that they don't have a clue how life began. We have had lots of scenarios, but we are running into a problem. There's a problem that intrigued me, and it's why I did my Ph.D. in biophysics, focusing on the information required to code for biopolymers. What does that how do you measure it, how do you detect it, and what does it do as far as protein structure goes? That's where I really focused on. But the information problem is really the bottom line, is what I would suggest ultimately is the steel wall upon which any tomato of natural explanation for the origin of life will find itself striking at a large speed eventually, is the steel wall of the information requirements. Another paper, Chance and Necessity Do Not Explain the Origin of Life, and it also makes a little more clearly the information problem here. This is the abstract. I'll read the last sentence in case some of you can't read it from back there. The reason, chance and necessity, another way of explaining the laws of nature and the random processes permitted within those law-like progressions. That's all we have in nature, is chance and necessity. Necessity are the laws. Chance occurs when you relax the outcome, when the laws are relaxed such that the outcome is not precisely determined. We call that chance. People argue whether chance really exists or not, but good enough for now. All known metabolism is cybernetic, that it is programmatically and algorithmically organized and controlled. That's the problem that they're focusing on. Again, it's the information problem. It's not just information as far as gibberish goes. It appears that the more we learn about gene regulation, for example, the more we are basically discovering that what the DNA is effectively, the information encoded in DNA is effectively software, highly sophisticated software, more sophisticated than anything we have ever written, where you have actually multiple packages simultaneously running, interacting with each other to determine cell fates and so forth. Another paper, I wanted to highlight one particular section on this. This paper, 3 subsets of sequence complexity and their relevance to biopolymeric information. They're really focusing on DNA, RNA, and proteins. They point out there are 3 types of complexity. Random sequence complexity, where the laws of nature do not determine the exact outcome, like I explained. There's ordered sequence complexity, where the laws of nature do determine the outcome very rigidly. For example, the structure of a crystal lattice is very ordered. But there's a 3rd type of complexity, and neither of the first 2 are what we're finding in the biopolymer.